Alright, in this video we're going to be looking at topic 9, which is the slopes and meanings of maximums and minimums of graphs. The topic of completing the square is going to come up in this section again. So if you want more practice with completing the square, we're going to see this again in this topic with question 25. So bear with me and zoom ahead to 25 if you need more help with completing the square. So we're going to start with interpreting a graph here. We have the percentage of a battery's capacity as a function of time shown in the graph. You might remember this from your very first quiz. What was the battery's level of charge when charging began? So here's my level of charge, and here's when the charging began. So we're looking for right when the charging began, which is this point on the graph, and it is 40%. At what rate is the battery charging? In order to find rate, I have to do the slope formula, which is rise over run. So we're going to pick 2 points on the graph, preferably with some whole numbers, easiest to compare whole numbers. I'm going to take this starting point right here, which is 0, 40, and I'm going to compare it to this point right here, which comes down to a whole number 5 and the whole number 50. So I'm going to look at rise over run. Now we can use the formula, which is f of b minus f of a over b minus a. In this case, it's actually easiest just to count the rise over run, but what we're really doing here is taking the ending y value minus the starting y value. That's going to do our rise. And we're taking the ending x value and subtracting the initial x value in order to figure out our run. So f of b is the number 50 minus f of a, which is 40. So 50 minus 40, it rose 10 units. So that was 50 minus 40. For our b and a, those are the x values along the bottom, so it ended at 5, it began at 0. So over 5 minus 0, which is 5. So our rise over run is just 10 divided by 5. So the answer for that is that it's charging at 2% per minute. So we get the number 2. Last question here is, what key feature does the battery's initial charging level represent? Now the important thing we're reviewing here is key features versus context. So a key feature is just looking at the graph without any story. So there's no story involved here. We're just interpreting a graph. So if I don't know units, if I don't know what the story is about, I don't know this is a battery charging over time, all I see are numbers on a graph and a line. Whereas context ties it to whatever the story is. So this is where I talk about the battery, and I talk about the charging level, and I talk about percent charged in minutes. That's what context is. So the key feature that the initial charging level represents is just this dot on the graph right here. So if I pretend this is any graph, I have no idea what the story is. All I'm looking at is the dot on the y-axis of this graph. Where my graph touches the y-axis is the y-intercept. And that's all I have to say about this point. It's the y-intercept. It's where my graph touches the y-axis. And I'm done. If it were asking for context, that's when I bring in the story, which is the battery's initial charging level in percent or whatever. I can tie it back to the story in some way. But key features just mean no story, just looking at it as a graph of anything. All right, let's take a look at question 24. 24 is again talking about the difference between key features and context. So the value is the key feature, just counting numbers, no story involved. And then context is where we tie it to the story. So we're going to basically match up key features and context. So here, value is a key feature, and value just means numbers with no story attached, just numbers. So price, that has to do with story. Initial cost, that has to do with story. But values are things like 7 and 20. So in this equation, I have my equation written in mx plus b form, the slope plus the b value, which is the y-intercept. So the value of the slope is given to me by the m value out in front, 7. That's the value of the slope. Whereas the number 20, that's the b value, that's the y-intercept. And these are just values. These are just counting numbers. They have nothing to do with the story, so nothing to do with representation, just counting. When it comes to representation, the slope represents this 7 here, It says this is the cost of placing a color advertisement in a newspaper. The slope tells me how the cost changes over time, and it changes based on the number of lines in the ad have been added up. So depending on how many lines I have in the ad, that's going to change my price. So the slope is representing the price of each line in the ad. N is the number of lines in the ad, so 7 relates to the price of each line. Now the y-intercept is going to be, again, this b value, the number 20. The y-intercept represents my initial point on the graph, which in this case would be the initial cost. And we match those guys up, and that problem's all done. So let's go ahead and take a look at a story problem. We're going to look at question 25, which is where we see completing the square happening again. So we have Anita and Emily testing out marshmallow shooters. They're both shooting from different heights. Anita's shooting from her bedroom window, Emily's shooting from the top of the slide. So Anita is over here on the left, Emily's over here on the right. So Emily is shooting from a slide and Anita's in her bedroom window. So we have a chart and a function talking about what happens to their marshmallows. So what is the maximum height that Anita's marshmallow shooter reached? So if we take a look at the table, which is the only information we've been given, so it's going to be the information we're going to use to interpret the value here. Anita's marshmallow started at 7 feet, went up to 9 feet, and then went to 10 feet, and then remained at 10 feet for a second. So it kind of stopped in the air. It was changing direction, and then started falling again. So this 10 represents the maximum height that was measured for the marshmallow. So we're going to go ahead and say that's 10. It's talking about height, so the height is measured in meters, so it goes up 10 meters. There we go, not feet, sorry. And part B asks for the maximum height that Emily's marshmallow shooter reached. Now, what we're looking for here, let me draw a little picture. Here's the marshmallow starting at a certain height. It flies through the air, turns around, and then starts going back to the ground. So we're looking for this point, which is the vertex. Now, Anita's was given to us in the table, but Emily has not given us the vertex of her function. She's only given us the equation. In order to get the vertex of a quadratic, I need to convert it to vertex form. And the process of converting to vertex form is called completing the square. So we need to complete the square here so that we can find the vertex. The vertex we're looking for, the part of the vertex we're looking for, is the height, which is the y value. And the y value is given to us in our vertex form by the letter k. Let me write out the vertex form here. Y equals a times x minus h squared plus k. So this k value is the point that we're looking for. That tells us the height of our vertex. So in order to get that k value, I need to take this quadratic and complete the square. So I'm going to go through the steps over here, see if I have enough room to do that in this section. So the first step of completing the square is to take our equation, we're going to set it equal to 0, and our first job is going to be to move c to the other side of the equation. C is the number 5. So I'm going to start with negative t squared plus 4t, and we're going to move that 5 to the other side of my equation. So I'm going to subtract 5 from both sides, minus 5. Now, our second step is to factor out a. A is just this negative symbol, which means it's a negative 1. So I'm going to factor out a negative 1 from everything on the left. I get a positive t squared. And positive 4t becomes negative 4t. I'm dividing it by a negative number. The negative 5 on the right doesn't change. Now my third step is going to be to go ahead and rewrite the left side. So all I'm rewriting is what's in the parentheses here. I'm going to move my squared to the outside of the parentheses and rewrite the rest of it as t by itself minus this b value divided by 2. Which is 2. Now, the last step of completing the square that we haven't done yet, let me see if I can move this a little bit so we can write that in here. Maybe? Nope. All right, that's fine. So the last step that I have to do here for completing the square that we didn't talk about last time we discussed completing the square is that I have to add a times b over 2 squared to the other side of the equal sign over here. We have completed the square on the left, we've rewritten it, and we've added an extra value. So to keep the equation balanced, I have to add that same value to the right-hand side. And the extra value we added is a times b over 2 squared. So let's go ahead and figure out what that's going to be over here where we have some space, and then we'll add it in this other equation. So a, remember, was just that negative symbol, negative. And the b over 2, we already calculated. B was negative 4, so b over 2 is that negative 2 right there. So negative 2 squared. So plus a negative, we're just subtracting this number, negative 2 squared. Negative 2 squared is the number positive 4, so we're just subtracting 4. That's what we have to do to this side of the equation. So we're going to do minus 4. So let's go ahead and take a look at what we get now. We get negative t minus 2 squared equals negative 5 minus 4, which is negative 9. Now the last step we're going to have here, which I'm going to write just on this side over here, the very last thing we have to do is just move the c value back so that we can take a look at what the equation is in vertex form. The vertex form has the k value on the same side as everything else. So I'm going to go ahead and just move the c value back to the other side. So the negative t minus 2 squared, we're going to move the negative 9 back by adding 9 to both sides. We get plus 9, and we can set it equal to 0 again, or h of t, whatever it needs to be equal to. So this is our completed square formula, and to find the height we needed to look for that k value, and the k value is positive 9. So the maximum height Emily's marshmallow shooter reached was 9 meters. So we did that by first moving c to the other side, second factoring out a, then rewriting our parentheses with a squared on the outside and b over 2, and then the last thing we did is we added a times b over 2 squared to the right side. Then when we move the right side back over, we can see what the height of the vertex is. All right, so whose marshmallow shooter went higher? That's going to be the one that was 10 meters, which is Anita's. And we have one last question. After the initial trial, the girls wondered whose launcher would have reached the highest point if they had both started at 7 feet. So we have to know what the starting height was of Emily's shooter, because Anita's, you can see, when they were at 0 height, she started at 7 meters high when they were at 0 time. So what we have to do is figure out what happened when we were at 0 time with Emily's shooter. So all we have to do is plug in 0 to her equation to figure out what her initial height was. So it would be negative 0 squared plus 4 times 0 plus 5. And if you remember, that c value is our starting height. So this is just 0 plus 5, which is 5. So Anita started at 7 feet, but what's her name? I'm sorry. We're paying attention. Emily started at only 5 feet. So they're wondering what would have happened if they both started at 7 feet. So in order to get Emily to 7 feet, she would have had to start up 2. So Emily would have to go up 2. And that would just move all of her values up 2 spaces. That's it. So all of her answers would end up 2 spaces. So they're asking what the new maximum height would be and whose launcher would have won. So if we take Emily's height and add 2, we would get 11 meters, which would be the new maximum height. It would be higher than Anita's 10 meters, which means that Emily's would win. And her new maximum height is 11 meters. We just raise everything about Emily's equation by 2 meters, including her maximum height. All right. Last but not least, for this topic, we're going to look at question 26. Thomas, Lewis, and Miranda are playing a game. Thomas is hitting a ball into the air, and Lewis and Miranda are just running wildly for basically no reason. Okay. So here's a function that represents the ball being launched into the air. T is representing the time in seconds. H of t is the height of the ball. So this graph is modeling the function, so it's a representation. And the first question is, for which interval is the function decreasing? Now, decreasing just means going downhill. So we're looking for an interval where we're going downhill. Now, the graph is going downhill in this area here. And so it starts going downhill at this x value here, which according to this ordered pair is 1.25. So that's where we're going to start decreasing. Now, for interval notation, we need to make sure to use either parentheses or brackets, depending on whether the value's included or not. Since we're decreasing here, we're going downhill, we need to figure out if the point 1.25, that's the height of the vertex, the x value of the vertex, if that's included in the point where we're decreasing. But if you'll notice, right at that vertex, that's when our function is changing from increasing to decreasing. And when I'm changing from increasing to decreasing, I'm not actually doing either one. I kind of actually stop in midair for a second. Think about like a cartoon. If I'm going uphill and then change to downhill, there's that one instant where I stop moving completely. So I'm not actually decreasing at that moment, but I'm about to. Next, we want to figure out where I stop decreasing, which is this x value down here, somewhere between 2 and 3. So that's going to be the ending point here. And in order to find out what that value is, I need to find out the x value of this parabola when y equals 0. So in order to find out that value, I need to figure out what x equals when y equals 0. I've got this equation here, and I need to set it equal to 0. The y value has to be 0. Now, I already know that this equation can't be factored nicely. The reason that I know that is because this number is between, this number is between 2 and 3. It is not a pretty number. It is somewhere in the middle. If it was going to be factorable, I would have a nice whole number down there, but I don't. So I already know that I'm not going to be able to factor. So I have to be able to solve this quadratic in another way. Perhaps there's some strange method of solving a quadratic including a formula, like the quadratic formula, which is exactly what we're going to have to use here. Anytime our number is not going to be a whole number, we're going to want to use the quadratic formula. So it is the opposite of b plus or minus the square root b squared minus 4ac all over 2a. And I'm going to fill in all of those values using the equation that was given to us. Now you can see the equation in front of you. This is going to solve for our x values, and we're looking for the x value that's between 2 and 3. So let's go ahead and fill in the values here. So x is going to equal the opposite of b. My b value is 40 in front of t, so negative 40, plus or minus the square root of b squared, again that's 40 squared, minus 4 times a is the value out in front of t squared, which is negative 16. It's important we get that negative in there, times c is the number 4, all over 2a. 2 times the a value. Again, the a value is negative 16. So I'm not going to solve this formula in parts. Your calculators, the yellow calculators, are actually capable of solving this all in one go. All you have to do is use the n over d button to type this in. You just have to do one at a time. Start with plus or start with minus and take a look at what both those values are. One of the values is negative 0.096. That represents this point over here, which we don't care about. The other one, you'll notice, is between 2 and 3. It's 2.596, and that's the value that we're looking for. It's between 2 and 3. So that's going to be the ending of our interval here, 2.596. Question B is asking about our rate of change between these 2 points that it gave us, between 0.5, that's this guy here, and 1.25, that's the vertex up here. So in order to do the rate of change formula, really all we're looking at is rise over run, which again, if you want to remember the formula, is f of b minus f of a over b minus a. So f of b and b, those come from the ending coordinate pair, and f of a and a come from the starting coordinate pair. So f of b is the y value from the coordinate pair, which is 29, and f of a is the y value of the first coordinate pair, which is 20. So that's the ending height minus the starting height. That tells me my rise, divided by my run, which is going to talk about my ending x value minus my starting x value. That talks about how far to the side I went. So we're going to do 1.25 minus my starting y value, which is 0.5. And if we plug that into a calculator, we get 9 over 0.75, which the calculator tells us is 12. So my rate of change is 12 which would be represented in feet per second. So feet is the height, seconds is the time, so feet per second. All right. Awesome. How long did it take for the ball to hit the ground? We're measuring time. Time is my x-axis, so I'm looking for how long from its starting point did it take to hit the ground. We actually already solved for that value. That's that x value we found, 2.596, and we can measure how long. That was seconds, so 2.596 seconds. And last but not least, what was the starting position of the ball? So that's asking for the starting height of the ball. Where did it begin? And if we take a look at my 0 time, that's my starting point. It looks like I'm near 5, but in order to be absolutely sure, I just want to make sure what happens when I plug 0 into my equation. So that's going to be time equals 0. So if I look at my function, it looks like 5, but looks can be deceiving. I want to take my original function and plug in 0 for time to make sure that I know exactly what happens at 0 time, so at the starting time. And I can see that that plus 4 is going to be my answer, 0, 0, and plus 4. So my starting height is actually 4 feet. So the graph is a little deceptive. Make sure you calculate for yourself what the starting height is. And that's it for interpreting that graph. So we're going to pick up with topic 10 in the next video.